Okay. Well, for people who are joining this live stream, this is one of our infinite series of meetings discussing incremental development in Wolfram Language. And we have apparently 3 small items and 1 big item to discuss today. So first small item has to do with this retry option.
Yes, so the idea, we discussed this.
I thought we killed this idea last time.
Well, what we killed is the idea of having a separate function for it. But you suggested that we explore this in relation as an option or to URL read, etc.
Okay.
So Ricardo has some idea there at the end, and also Francisco is here for the discussion from the point of view of connection to Wolfram Alpha, etc.
Okay, so wait a minute.
Yeah, so that was the original idea. And so we are exploring now the possibility of having a retry option.
Mm-hmm.
And the question is, what will be the syntax for the retry?
Well, so this is a retry function. That would be a retry function for things like URL read.
Right, exactly.
Is Fahim here by any chance?
I asked Fahim, and he said Ricardo is the relevant person to be in this discussion.
Is Ricardo here?
Yes, he's here.
Yes.
Okay. So what are you proposing here?
It's very easy. Basically, most of the time you will need to retry the response if something happens. For example, like the cases we want to retry, it's either like it's a server error, and if it's a server error, probably you want to retry it maybe with incremental time. And so this function could either return like true or false, or it could return a time, basically a date object when you want that to retry again. But actually, this cannot really happen in the scope because you need to retry it synchronously. So it's just a yes or no in this case.
Okay, I'm confused. We're looking at 2 different things. We're looking at, we've got URL submit, which is an asynchronous thing.
Right.
One thing that could happen is asynchronously, you're trying to get something returned from a URL. The server, is not returning stuff. But then you want to keep going later. Somebody is making a very weird noise on the phone here. Okay. So that's that case. URL read is a synchronous read, right? It's a blocking synchronous read.
Yes.
Okay, so what are you proposing here?
For this function, just true and false. I don't know if it's possible to implement for URL submit something else than just true and false.
Well, so the question for URL read is, should it be retried?
Right.
Is that the question?
Mm-hmm.
But you're saying without a pause, or you're saying with a pause?
Without a pause. That is true. Yeah, maybe in a synchronous environment, maybe it doesn't make that much sense now that we are thinking about it. Because if the server was down, then
the server is still down.
Yeah.
Unless it got routed, unless that particular, request got routed in some weird way or something like that. We perfectly well. Okay, so we have a time constraint, don't we, in URL read?
There is a case where basically 500 zero errors, you might want to retry them for like 3 or 4 times. And if the server keeps returning an error, then, sometimes it just happened that, for example, like a getaway error. And then basically what happened is that the underlying service is not responding. Like, I don't know, Apache cannot find, Python or Node that is running underground.
Okay.
That can happen, but it's true that, basically after 4 or 5 times that you do it synchronously, doesn't make that much sense to keep retrying synchronously. You will want to wait.
I understand, but that's already, okay. Look, the various possibilities here. One thing we could have is a thing called MaxRetries, right? In addition to time constraint, which we have here, right?
Right.
In URL read right now, we have no retries. We never have a retry. right? So max retries by default will be 1, right?
Right, and you will need to comment in which, if you don't provide a function of the result, then you will need to describe what are the cases you are retrying. And I guess sensible case will be, if the server is returning 5-0 kind of errors.
Okay, but the two things that are, okay. So you're saying we need to know what counts as a failure.
Right.
And how many times to retry.
Which is why I was thinking about having like a function.
Okay, and there's a third thing, which is how long to wait between each retry.
But you cannot really do it. I mean, you could also wait, but that will block the kernel in this case.
So what? It's okay.
This is basically the design that curl has. For example, if you see the man page of curl, I put that in the Zoom chat, and search for --retry. You have there 4 options to.
So they've already invented this.
Yes, but they don't expose that in the library, by the way. That's why we don't have that in URL fetch and family. So this is something they have in the client, in the curl client. The number of retries, how much time to wait, and how much time to wait between retries. And something else that I think we will need is what considered to be a failure that might be retry.
Yeah, well, that's what
yes.
Ricardo was just saying.
Yes.
Yeah.
And I wonder.
Yeah, go on.
That's the case where I think a function will be the value for that option, and the others could be the seconds, the number, etc. I think that could be easily used in almost in any case, I think.
Okay, so time constraint, we currently have time constraint, which is similar to this.
Right.
Which is the overall time that you can possibly, that's the
well, it's not really the same. Time constraint is how long you wait before considering a timeout, basically. So if the server might be saying, yeah, this is the response, but then it takes 2 minutes or something, and you might, But time constraint, it happens, the server is responding. It's just that it's taking too much time, and
Okay, so one possibility that we could have is, we could consider something like retry rules, and it's an association which contains a bunch of different things. We could consider, what are they called? The 500. What the heck is 500? What is that called? What is the category of thing which 500 is? You know what I'm talking about?
Error.
Backend errors.
No. I mean, what is the code?
The status, the return.
Status code. Yeah, right. It's kind of like, what do you consider to be success? What do you consider to be failure? I mean, there's a bunch of different things here. And that would be, rather than giving a function where you have to have all kinds of, code there, one could...
No, not really. I mean, the response, if you just ask for the status code, gets back the status code. And then you just need to say, if status code greater than whatever, that will return the true or false. And attempt lower than, I think it's a synthetic and kind of easy code instead of having the specification, and it's rather more powerful to have a function that can actually inspect the whole response.
So you're proposing that it says retry function, but unfortunately that word means that's the function to use to retry. That's, really what it is more is this is a test for whether to retry. Am I making sense?
Sure. Or just retry test, maybe.
Okay, but what are you proposing then as the actual... You're proposing as a function which takes what as its arguments?
Well, what you can do is basically hash status code greater than 500 and hash2 lower than 4. Like, yeah.
No, but this isn't giving the pause, right?
This is not giving the pause. This is just true or false, right?
I see that should be complementary to other options regarding this retry number of times, retry, etc. So I will use the retry condition only to test the HTTP response, so that in case you want something more advanced, like inspecting the content, the actual content, you can use that, etc.
So you're suggesting that there's a retry pause, which is just, however many seconds or whatever.
Usually the retry, it's, exponential.
Yes. Right. I mean, yeah, okay, so how do we represent that? I mean, here, then, this might return, how soon to retry.
Right. If you return none or false, that could be stop it.
Otherwise, you return a time.
Otherwise, you return a time, right.
I mean, it's a little bit of a weird thing, retry time function. Well, okay, retry time function to none means don't retry. Retry time function to a number.
0
do that.
now, yeah, sure. 0, yeah, return. It will be immediate, and n will be seconds, I guess, and then you can use quantities.
No, I don't think so. I mean, retry time function, I was thinking that means the number of times to retry. In that case, that's a shorthand for number of times to retry.
Ah, sure. Oh, okay. Mm-hmm. Say we create the function from that. Yeah, sure.
Otherwise, the arguments are the arguments to the function are the return value, the most recent return, and the serial number of that return. See, one thing we could do when we return something, when we return the packet, why not return that serial number in the packet? Or is that crazy? Your read returns an HTTP response, right?
It can be done. It could be a property, yes. It could be a property. So, yeah, in the second argument, you can say retry number or something.
Right, but then what would that actually be? So that would be part of HTTP response, right?
No. That would be just a property of URL read, I guess.
Why?
It's not really part of the response. It's
well, it could
because you want
inside.
Yeah, second argument is metadata. Yeah, is really strictly not part of the response. Some kind of metadata that you are attaching it, but yeah.
Yeah, I agree. We should not include anything related to this retry to the response.
Yeah, it doesn't quite seem right. But okay, so then the idea is this returns a time to retry, time to pause before retrying. Okay, so in the exponential backoff, it will be 2 to the power serial number or something like this, right?
Right.
Is this useful? I mean, is this whole thing useful, do you think? Retry time function. It seems somewhat useful.
I mean, you will need to implement it yourself if you want to retry.
Yes, but I feel it's a bit complicated for the most common cases where you only want like 5 times to retry or.
But that's what I want this case for. That's why I'm saying do this. Retry time function arrow 5.
Yeah, but also if you just return true there or 0, that will mean, retry synchronously 5 times. You just need to return 0.
What are you talking about? I mean, I'm just saying.
From the function, yes. No, this is what I understand, Stephen, but I'm also saying that, also from the function, it's pretty easy to do that. You just need to return, a small number like 0.
Okay, so the other possibility would be retry time function. So it seems to me the two sort of courtesy cases are that and the quantity case where you can give a time.
Yeah, but then how many times?
It's a good question.
Until you reach the total timeout?
How many times you retry with that one? I mean, yeah.
No.
You can assume 1, but
no. You keep going until you hit the time constraint.
But time constraint is for a single request.
Yes, I was wondering if it should be. So right now, time constraint is for a single request because we are not retrying.
Yes.
So how are we going to interpret the time constraint?
Well, but I don't understand. In the case where you still got to know how long to wait for a single request before you try a retry. So I agree that we need a parameter that determines how long to wait for a single request, right?
Yeah, and that would be time constraint.
Okay, so this one is single request. So there's no overall if it's larger than this amount of time. I mean, arguably, what we could do here is we could have serial number and we could have total time so far as a third argument.
I'm not sure if time constraint should be only for single requests.
But you have to specify how long to wait for a single request.
No, I agree. But what I mean is that time constraint is used in many other cases as always meaning the total time for that function.
You're right. So that would suggest that we need a
single time, or we can reuse. Also, we have all other timeout options in URL fetch, like for example, connect timeout, read timeout.
But I think we're really complicating it. I mean, this quantity stuff is not really useful if it's not exponential in any case, I think.
Because it's not what?
If it's not exponential, it's not useful. And you can express easily with a function, and we can actually make, a couple of examples that people can just copy and change time.
Sorry, I'm not clear. The claim that there are timeouts, I'm not seeing a timeout. Oh, time constraint. Oh, gosh. Look at that. Look at that. We've got a more elaborated time constraint here. So we perfectly well could have something in time constraint called total, which could be the default. Do you see what I'm saying? Right, because time constraint right now has an association which breaks down the time to connect, the time to read. Make sense?
Mm-hmm.
Anybody got any idea where I can put this? Do you know, Sushma, do you know if we have...
we have a folder called language functions if you want to put there.
No, I don't want to put it there. I want to put it in something to do with URL.
I don't know if I don't think so. We have any folders like that.
Wow, okay. Weird. I'm going to somewhat unreasonably put it in, oh dear, where should it go? I'm going to put it in import export, and you're going to remember that it's there.
Okay.
No, actually.
Miscellaneous.
I hate to put something in miscellaneous. I can't even imagine what would be in miscellaneous. Well, okay. I'll put it in miscellaneous.
Okay.
Under retry function.
Okay.
Okay, so let's loop back. What are we concluding here? Okay, so in here, we consider the possibility of saying, total. Oh, gosh. This has to be broken into per request. And do you get what I'm saying? Something like all requests, arrow, whatever.
And another per request, in case you don't want connecting and reading separate.
Yes.
But no, that would be just the sum of count, connecting and reading.
That's correct. But if you do, right, so that would be the thing with, that's per request is the sum of connecting and reading. All requests is the timeout allowed. So you can have, okay, so that will be a possibility for that. Then here, what we're suggesting is retry time function, which returns the time to pause before retrying, or none if you don't want to retry. Is that right?
Right.
Okay. Okay. Well, this seems reasonable. Who would implement this?
It would be either me or Kwan, maybe.
Or who?
Kwan. I remember the last name.
Okay. Is it easy?
It's tricky. URL fetch takes multiple requests, so it's just a matter of filtering out the one that failed, then keep retrying and return. Just
okay. So, question: what about URL submit?
Not sure about that. Unfortunately, we will need to ask to Konstantin.
Okay. Yeah. All right. Well, why don't you do that? And let's consider this, this is not the highest priority thing, but let's try to keep this moving forward.
Sure.
Make sense?
Okay.
Okay. Thank you.
Thank you. Bye-bye.
Okay. See ya. Okay. Next up, next date taking day names. Wow. What on earth is this?
So the basic idea is there was a suggestion that if you say next date of Tuesday, it should give you the next Tuesday that's coming up as a date, or previous date of Tuesday, it should give you the previous Tuesday. And what we wanted to do is, those particular elements of it are not hard to do, but we wanted to look at the day name functions are all related to sort of a parent categorization of dates, which are called day types. So we have the days of the week, Monday through Sunday. We have weekday, weekend, end of month, beginning of month, and then holiday related things. And so we wanted to apply the same basic logic to these functions, but we also needed to sort of sort out what we want to do with current date, because if we say current date of Tuesday today's not a Tuesday, so it would either have to give a date that's not the current date, or it would have to give an error. And when Jose and I were discussing this, we felt like it's more consistent for it to just give an error in those cases rather than arbitrarily.
I think that's crazy to just say. I mean, in other words, next date of Tuesday seems to me to make some sense. I mean, in other words, so next date. So, for example, what happens if you say next date of weekend?
So right now, we don't support these particular parameters, but in looking
are we intending that to be a granularity like day and month, or are we?
So all of these day types have a granularity of day. That's where, the original version of next date, previous date, and current date all take granularities, but they don't take things like day types, because day types are all a day. They're just a particular qualification for a day. And
okay, but wait a minute. If I say next date of a weekend, do I get the date interval that corresponds to the whole weekend? Should I get the date interval corresponding to the whole weekend?
I don't think so, because I think the implicit granularity of all of these is a day. Next date of weekend is saying, give me the next day that's on the weekend. So if you did it right now, it would give you this coming Saturday. If you evaluated it on this coming Sunday, it would give you the following Saturday.
That's what day round is doing right now, right?
Yeah.
What does day round do?
So day round takes a date and a day type. So you can, if you say day round of now, it will give you today. It will basically round it the day out, which uses the current day as the default. If you said day round now, comma, Friday, it would give you this coming Friday.
Comma Friday?
Yeah, Friday is a symbol. Mm-hmm.
I don't understand that. Why did it do that? What does that even mean?
So the second argument is a day type. You're saying, I want to round today to the nearest Friday, or by the default rounding system, which is current or following.
That's really weird.
Yeah.
That seems weird. I mean, if that is a way of getting next Friday. I mean, the next up Friday, and it seems a much better way to do that would be to say next date of Friday.
Yeah, I think, when we weren't originally thinking about the day types when we created next date and previous date, but I think, based on the function name and the general design, it makes a lot of sense to do that. I just wasn't as sure if we wanted to generalize that to all of the day types, or we wanted to just say, well, we'll do it for days of the week, and for these other things.
Okay, but I'm concerned about when you say next date of granularity, effectively weekend, that you're not getting the whole weekend. That seems wrong to me.
Granularity, sorry, weekend is not a granularity.
I know it's not currently a granularity.
Mm-hmm. And I don't think Friday is a granularity either.
Right. Granularity is something which can partition continuously or fully the time access, like weeks, months.
In principle, there's no gaps in granularity. There are gaps between Fridays, and there are gaps between weekends or holidays.
But so how would I get the span of days which corresponds to next weekend?
I mean, right now, we don't have a specific function to do that. I mean, you could set it up using a day range, or...
But then you get a list of days.
Yeah.
But date interval is supposed to do that, isn't it?
I mean, date interval is supposed to be the symbolic representation of a range of days, yeah. But in terms of, I mean, most of these date functions are set up to return a single date. And in terms of having, I guess I haven't thought really extensively about what next date of weekend would be, other than saying, if we're treating these not as granularities, but as day type specifications, we're getting the next day type that matches.
All right, but we've got two issues here. One is, how do we get the beginning of next weekend? And then how do we get the full interval of next weekend?
Mm-hmm.
Right? Those are two different things. And what we're doing with granularities right now, we've got the moment at which the weekend begins. This is a complete week, right?
Right. Mm-hmm.
So if I say current date, yeah, so that's correct there.
Mm-hmm.
So, okay, so the issue is, again, we've got these two different cases. Give the span of the next weekend. And we've also got give the beginning of the next weekend. or give the beginning of the next weekend to granularity X, e.g. day, right?
Mm-hmm.
Okay, so how do we represent these? Because right now, next blah, 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 next date just takes a granularity, right? And as you say, those granularities are arranged one after another.
Mm-hmm.
I mean, I think let's see, next date. Gives the next date of the given granularity with respect to the specified date. So in a sense, there's a pseudo granularity, which is interval. No, there's a meta granularity, which is interval. So in other words, you can say the interval of days corresponding to the weekend, or you can say the interval of seconds corresponding to the weekend. Get what I'm saying?
Yeah, I mean, the general notion of date interval as we've conceived it thus far is to represent a continuous period of time. It begins at one moment, it ends at another moment.
Great, but that could be, but do we potentially want date interval to also know a granularity of things inside it?
We had talked about potentially differentiating between having a date interval that is always a full collection of instants versus a date span that could have either a period associated with it or a granularity associated with it. But the main sort of abstraction is that the granularity of the date interval is more interesting on the specific operations that you're working on it. So if you take a date range of a date interval, then you could say, I want it in this step size. I don't know if it's as useful to say this is a date interval from this instant to this instant, but the implied step size associated with it is years. Because
okay, fair enough.
Yeah.
Okay, but do we currently have weekend for anything? Is that currently a thing?
So we have weekend as a day type. It's used in the various day functions: day match queue, day round, day count. So I have a list of those on your left-hand notebook. And
so
those
if I want to find the next weekend, how can I do it?
So if you do day plus of today, comma weekend, it will give you the first day that matches the criteria of weekend. So it will give you Saturday. Oh, I'm sorry, 1, yeah. And if you add one weekend to that day, it will give you Sunday. And if you add another weekend to it, it will give you the next Saturday.
What do you mean? If I give 2 there.
Yeah, if you give 2, it will give you the Sunday, or if you put 3, it will jump to the next Saturday.
I see. So that's a criterion for day plus. That's adding a certain number of days with a criterion that they must be those kinds of days.
Correct.
Okay, which is different from saying jump to the next one of that thing. Right? So, for example, your jump to the next Friday. Okay, so that would be much closer to jump to the next. So the problem is next date. Yes. I mean, to me, next date of weekend should be some kind of date span of next weekend. Because given date span and date interval, we're going to have functions that get us the beginning and the end of that interval.
Yeah, I guess the slightly complicated thing is when we look at the, weekday and weekend are used sort of in parallel, where the name of this probably isn't as great because weekday, if you say next date of weekday, you don't expect to get the whole span of weekdays. It's referring to a singular element within that, and really weekend is weekend day. But
right. Well, so that's what we should call it. To not to So we've got the notion of a weekend day and a weekday, right? Which are criteria then. Okay, so what are you proposing? You're proposing that next date. Okay, so if we said next date of weekend day, then I quite understand that it's going to go to the next weekend day, just like day plus goes to the next day that satisfies a criterion.
Okay,
right?
yeah, I think that's
a more general.
clearer.
Okay, so then if it's next date of, so what we're now saying is, it's either a granularity. So actually, we need both cases. So ultimately, we could have here. All right, so we have the possibility of a date there, but in addition to granularity, so we either have a granularity or we can have a type, basically. With a default granularity. These ones would have a default granularity of day.
Right.
So then the proposal would be, if it's next date of, and we could accept both the symbol and a string as courtesy of, let's say, Friday, for example, then that would again have default granularity of day.
Correct.
And current date of Friday, if it's not a Friday, would just give an error.
Yeah, I think that makes sense. And we're looking at adding a calendar granularity option to specify granularity, so we could use that to increase the precision of the granularity. I don't think saying next date of Friday granularity goes to year makes any sense. I mean, I guess you would basically, it would maybe be useful at the end of the year when you're transitioning over and say,
wait a second. What are you saying about calendar granularity? Why? I mean,
so we had talked about adding an option called either date granularity or calendar granularity,
which is an alternative to giving the argument.
Right, as an alternative to giving the argument. Say I want a date range from this date to this date, but I want the outputs to be in this granularity instead of whatever they would be normally.
Oh yeah, I think that's reasonable enough.
So that.
Okay.
And that avoids us having to add an extra argument in to handle variation there.
Okay, but so what other things are they that, in addition to weekend day, I mean, there's potentially holiday?
Yeah, there's the holiday or business day, which is a weekday that isn't a holiday. The only one I can think of that isn't a day type that might be useful is leap year. We have leap year Q, but we don't have a way to say, give me the next leap year. I mean, it's pretty straightforward to know what it is, but
we want both of those, presumably.
And then each day of the week, and then we also have end of month, beginning of month. I don't.
Those are days.
Yeah, those are days.
So I think month first day, month last day would be clearer if the default granularity is day. And, week first day, well, you can pick, Sunday, Monday, whatever, because they have names.
Right, yep.
I mean, one could imagine year first day as well. And that's where it starts to get down a slippery slope.
Right.
And how could you specify things like, for example, second Friday of the month?
So those, I mean, that's when you start getting into things like date select, where you want to either use some sort of scheduling notation, or you want to have some general pattern to say, I have either this explicit or implicit range of dates, and I want the days that I want the second Tuesday of every month, or I want.
How do you do that, though?
So that's something that we're working on as an experimental function for date select. It's one down in my queue right now, but we basically use the keys associated with date value, where you can set up a criteria, we can compile it down, and then look at a range of dates and say.
But how do you do the second Tuesday or whatever?
So in that case, we'd need to either have something like cron notation, where we have, division forms, which I don't think is particularly good, or we can have extra criteria where we say, it's after, excuse me, that it's after a certain criteria within the month. It's a little tricky to sort of generalize the form and say, I want the second Tuesday of a given month.
Well, one issue is whether we have decent, control equals linguistics for some of this stuff. Carl Lang on our live stream is asking about lunar months. And there's a horrible silence.
Well, we have the quantities for all the various types of lunar months, the draconian months, etc. But we don't have a way of determining the beginning and end of them right now.
Although we know them.
Yes, I guess we do. Just by computing the position of the moon and the Earth. Yeah. We could compute it. Just I don't think we have a syntax for them right now.
But that is an interesting thing oh boy. Right now, we could imagine a granularity of lunar months.
Well, we have been so far distinguishing the units from the granularities. And we have lunar months and various types of months as units, fixed duration, but not as granularities.
Right. The granularities are very closely tied to the calendar. There are granularities that make sense in a Gregorian calendar that may not make sense in the Islamic calendar or in the Mayan Tzolk'in calendar, because they just don't have the same unit steps.
Okay. So where does that leave us with lunar month?
For example, these lunar months, etc., they are typically average, because they are not all exactly the same and depends on where.
I understand. Okay, so it's not the actual position of the moon, is what you're saying. We're not asking when does the moon exactly, because that's the draconic month versus the I forget what all of those are, right? All
yes, synodal, synodic month, etc.
Yes. So what's your point? So to know when.
My point is that once we have the astronomy functions, they will be able to compute all these things because they will depend on time. Right now, the only thing we can offer is the average amounts stored in the unit framework.
I see. So this question about lunar month, basically we should wait until we have the proper astronomy framework.
Exactly.
Which is going to give us the exact answer to when is the moon next in this position relative to this and that.
Exactly.
Okay. Yeah. But that doesn't answer the second Tuesday of the month question.
No, that's different, because that's fully dependent on the calendar, as Nick says. And we'll have just to invent a notation for that.
But is that... What happens if we say like the 8th Tuesday of the month?
I would just, like we do when we say the day 100th of February, we compute something in May or something. I would do the same thing.
Okay. But so what you're saying here, this is month first day. basically,
Yeah.
So because we can get, we can get the first weekend in March or something.
Mm-hmm.
That's another typical type of thing.
Mm-hmm.
But then we've also got, we support a lot of the stuff in Wolfram Alpha, the first Monday after Christmas. Right, we've also got things like that.
Yes, so computing these things is not difficult. It's simple arithmetic. The problematic thing is how to represent them.
No, I understand, but we've got day plus will count. That gives us the first Friday off to today, right? Is that right? Is that what that means? Day plus.
It says, yeah.
Yes, if you try to, it will give you the next week.
Will it give me the next Friday?
Yeah.
So that's exactly doing this, right?
Mm-hmm. It's just that the criteria that you can provide is a limited set of types of days. So, basically, if we say the first Monday after Christmas, we just need something that determines in the first argument when Christmas is, and then plus one Monday.
Okay.
So any of these sort of more elaborate combinations just usually involves a couple of steps where we compute whatever reference date we want is, and then we add whatever we want from there.
Yes.
So I think the short-term takeaway is it's pretty straightforward for us to take the list you have here of weekend day, weekday, etc., turn those into arguments we can provide to next date, current date, and previous date.
Right. But by the way, if I say second Tuesday, next Tuesday, if I just do that, do we get the right thing here?
Should, yep.
Magnificent. Okay, so let's say second Tuesday of May. Oops, it would help if I didn't say second nanosecond. Oh my God.
Well, that's interesting. Yeah.
Second Tuesday of May. This is not looking good.
Yeah, I think it's going to give the results since there's not.
Okay. Well, we don't lose that many points for that. That wasn't that horrible.
Yeah, I think the slight delay was that it was checking for the Wolfram language representation and then checking for the result. But yeah.
Right.
That kind of rules of second something of a month or last Friday of a month, for example, it's there are a lot in the time zones specifications where they say, for example, the time zone daylight saving will occur the last Sunday of this month or that other month. So we have all
right. There's a whole scheduling notation for holidays and other things.
Yeah, I think we need to look at that notation. Okay, this needs to come back another time. Okay, I think this stuff is implementable, but this needs to come back another time.
Yeah.
Right? For that notation. And what is the status of you actually working on this, Nick?
In terms of the more complicated scheduling notation, or being able to do
no, on dates in general.
On dates in general, I'm working on it actively. We're wrapping up the big work that I've been doing on updating the quantity implementation for the next version, which should get merged in a couple days. And we're doing some of the things we've talked about dates in the past few meetings in time object. So
okay. And what about the temporal logic stuff and the time after and so on?
So that we've been continuing some of the discussions in our weekly dates meeting with Jose. That's still largely in the design phase of figuring out what the language representation of it's going to be and how we interact with things.
Okay, good. All right. Well, so we made some progress on this today. Good. Okay. All right. So I think that's it for that. Let's see. We are over time, but I think we should let's at least try to go through a few of more of these things.
Yeah. So the empty suggestion, this is a suggestion of having a function which can identify what the meaning of emptiness of an expression which is empty. It's problematic because the immediate question is whether this is structural, and so it means length 0, or it's more like...
Yeah, I think it's horrendously complicated. Where did it come from?
We have a developer MTQ, and some of our developers in-house find that quite useful. So they suggested that we promote it to system, but of course, immediately we started suggesting or complaining about various problems of that idea.
I don't see it. I mean, I think it's I just don't see it. What is an empty list? I mean, what are some things we might consider? We might consider...
So we had suggestions like empty graph.
Right,
yes.
so empty list, I mean, what are the actual expressions? Empty queue of a list, empty queue... What is an empty sparse array?
Well, all our definitions of arrays will immediately convert into empty list to have a unique representation of it. So sparse array of that thing you have there will convert into an empty.
But this will not.
Yes, that will not.
That's just a bunch of zeros.
Right, correct.
Okay. But sparse array of nothing like this, does that auto-normalize?
I think if you give a length, if you give 0, length...
Well, okay, if I give 0 then as the length, then no doubt. Then it will certainly, okay, it does that.
Exactly, but you see, it doesn't have head sparse array anymore. That's what I meant.
Weird, yeah, right. Okay, so is empty queue of the empty string supposed to be?
Right, so Roman was suggesting that empty queue would know about the different types. And then it would say true in this case, because it knows what's an empty string.
What other kinds of things can there be? I mean, empty, is there an empty audio object?
Right, things like empty graph, for example, graph of empty list of edges.
Okay, but what about the following possibility? This with a bunch of options. Is that still an empty graph?
Right, that's a structural versus semantic question. Yeah. So I do find this problematic, but we wanted to check with you.
Well, I mean, who is championing this particular thing?
I think Roman started the discussion and he was suggesting.
Roman here?
No, he's not here.
Okay, let's. Can we get a specific list of things we think are supposed to be empty? Patterns we think are supposed to be empty.
Okay.
I mean, I also wonder a little bit how this relates to the type system. I mean, an empty, each one of these things. Yes. This is complicated.
Yes, so it could be natural to have a second argument which says, I'm considering emptiness of this particular type.
Yeah, I think this is going down a slippery slope because I think you can just test for that if you want to.
Right. So as I said, to me, the most problematic thing is the structural versus semantic thing, like in the same way that we don't have a function like real queue. So do we mean the type, structural type, or? I
don't think this is going anyplace. I mean, you could send it back to Roman, ask for a list of what he thinks the patterns of emptiness are supposed to be.
Okay.
Okay. We are really over time here, but I mean, do you want to take a few minutes to look at this? Is that going to be useful, or does this going to really require a longer discussion?
Well, it took quite a long time last time we went through this, though there is a main question there, which is this thing in red, which is one of the things that I find more difficult to decide, which is how to express relative errors versus absolute errors. Because the standard way people do it is like adding plus 33%. But of course, because not normal of 33% will give 0.33, then it gets converted into a number, and we have this ambiguity of whether we mean actually 0.33.
Well, I think we have to say scaled. I think we have to have a scaled wrapper there.
Scale right now auto-converts into the absolute. So perhaps
I think that's wrong. I think what we need to do is to have a notation in the plus minus thing that indicates that it's a relative error.
I see. So we keep
let's talk about what that is, right? So we keep the scaled, and if it is a relative error, is Michael here? I don't know what.
No, he's on PTO.
Sorry, what was the answer to the Michael? Michael is.
He's not here. He's on PTO.
Okay. Okay. So, I mean, my feeling is because Michael would quote the standard somehow. Maybe you can quote the standard. I mean, is there any? I don't think it's right to convert these scaled things to absolute. I think we have to maintain them.
Okay.
And because I think that it is useful if you are doing it. So one question is, if you combine something with an absolute error with something with a scaled error, what do you get?
I would say absolute errors. Okay. This is more like for representation.
But if you combine two things with scaled errors, what do you get?
My tendency is also absolute errors. So somehow, perhaps we need a way of forcing the representation, the relative representation back.
We had some kind of a round form, didn't we?
We discussed about it, but we don't have it yet. Yeah, this may be one of those cases in which we need
right
a round form.
So, yeah, okay. So the question then is the display of plus minus 33%.
Right.
In other words, how do we?
That's a standard in the literature to represent something with a percentage error.
Okay, but I think we need a decoration here. Did we not agree that the error is going to be in smaller font?
We discussed that last week, yes. So I'm not sure we agreed on anything finally, but we considered several ideas.
I thought we'd agreed that we were going to use a smaller font for the error. I believe.
Yeah.
Sushma, can you tell us?
Yes.
Can you remind us?
I mean, we didn't agree, but that was something which was strongly
yes
mentioned. And I think you also mentioned us to take it to design. So.
Okay.
Yes.
Hey, where am I storing these things?
Uncertainty.
So then I think the first thing I'm going to do is to avoid scale getting auto-converted.
Yes.
And then we proceed from there to see how it works.
Okay, but hold on. Let's just a minute. Let me just what was the one from last week? Is this
uncertainty examples?
05, I think. I'm putting this in 06. Okay, but could we maybe Jeremy could join us for a minute if we can find him, and we could talk about this design thing.
Okay. Which Jeremy?
Davis.
Okay.
I have to open this in prototype build, right?
Yes, the functionality is in the prototype build.
Okay, this was our notes from last time. Right?
Yes.
So the asymmetric case already has this. Okay, so this is what we discussed, is looking like this, right?
Yes, and Michael liked that too.
Okay, so now what we have to do is the relative error. What does relative error look like? Right?
Yes, so the standard thing to do is to present it with a percentage.
Fine, but putting a period behind the percent is definitely a loser.
Well, this is following the 2 significant digits rule.
I know that, but it shouldn't have a period there. It should be 33% because that's the 2 significant digits, not 33 dot.
Okay.
I mean, that looks really weird, the 33 dot. But I think the question is whether it's confusing. I guess if this is in a smaller font, then it becomes less confusing. I mean, okay, I don't know if I can do this here, but oh gosh, I don't even know how to do this. But let's say it's 25 and
Jeremy's here.
Hi there. Plus minus, let's say it's 33%, and then that 33% is smaller. Why isn't that going smaller? Oh, there we go. Okay. So that's smaller, and maybe it's gray, or maybe it's got a that's probably not terrible. I mean, that's reasonable. And then the alternative would be, we're talking about, Jeremy, numbers with errors.
Yeah. So tighter probably to the equal, the plus minus.
What do you mean?
Just a little. It's a little spaced, a little too far away, but smaller is good. Just a little tighter in the letter
Right,
spacing.
do you think we should center it? I think we should center this. Or do you think it should be to the baseline?
Gosh, it's probably like 2 pixels there. I could take a look. Probably center. I'm sure as font size gets bigger, it's going to look better centered.
You know how to move this? Does anybody remember how to do the how do you do
like a baseline shift?
Yeah, but how do I do what is it? I am trying to do a nudge. How do I do nudge? Did we take that out of the
it has to be in a box, an adjustment box first, and then you can nudge it even with
right, but I thought we had a way of doing nudge. Where is our typesetting stuff? Where's all the stuff to do with enter? Oh, typesetting, there we go. Nudge up, nudge down. Oh, well, that's a bug. Well, that's a bug that should get reported.
Okay.
Okay. Okay, in any case.
Did you click on nudge up?
I clicked on nudge up.
Okay.
And the thing went bonkers.
Okay.
In particular, well, it did do a baseline shift, but then somehow the payload disappeared. Okay, but in any case, and I wonder if we should go gray or not bother. But you think we should go vertically, we should go a little tighter. And for this relative error, where we have a %, so we'd say scale to 0.33, whatever it is, but the print form will be 33%. Correct, okay. Jose?
Yes, exactly.
Okay. The other issue is that we would like to distinguish this plus minus, Jeremy, from the plus minus that we enter with escape plus minus.
Okay.
It's kind of a mess.
Perhaps precisely the size, the fact that it is smaller.
Yeah, I think that will certainly help. And that suggests that the plus minus also be smaller in addition to the, and there's also a case, Jeremy, where these things are, where this case here comes up, where they're asymmetric errors, which I think is fine and consistent. And that argues for centering for the single plus minus.
Yeah, and a little bit of lightening, like a little gray makes sense too.
Fine. Well, that seems to have the right tightness to it.
Yeah.
Okay, why don't you just spec what this should be, and Jose can implement that. Is there any other formatting issue that we have here? Oh, I mean, we've got the case of, what are we doing with the case where we have a round with some more complicated argument structure, like the correlation matrix?
It's not being formatted. When it gets very complicated and there are many numbers, it stays without formatting.
Okay, fine.
We discussed the other cases. You remember the Avogadro number, in which people put in parentheses.
Oh, yes, that's the other case. Right, that's the other case. So that was part of the around form.
Right, exactly. That's where we were discussing around form to control those things.
You should have examples of that on the bottom.
in here.
Yeah,
it's there. Right above, no, above the.
No, this was my suggestion. Right.
Yes.
This was my suggestion for what to do.
Yes, we had the example before this entity call. If you go a bit up. Right there. Yes, I was presenting that in parentheses.
Right. Which turns out, Jeremy, I had been going all these years thinking that that meant the 74 was the next two numbers here. Okay.
Okay.
Turns out I'm wrong.
What is it?
So,
I don't know what it is.
Well, here's what it is. It is a plus minus error for the 57. Isn't that wild?
So it's multiplication with a plus. I still don't get it.
No. It's this, okay? It's those last two digits, the 57, the 57 that's there. Those digits are uncertain.
Okay.
And so what it really is plus minus 0.000000, then those digits.
Okay.
Right? Which is, I mean, I'm totally embarrassed that like all these, I mean, not that I've ever needed to use this, but all these years I just got it wrong, what it was. So what I was proposing was this kind of approach where we basically gray out. We use a round form to specify how we want this done, and that could also control the percentage, for scaled things. But what I'm suggesting is that the digits which are uncertain are somehow grayed out and paired with a plus minus for those digits. See what I'm saying?
Yeah, I mean, I like what's below a little better where the numbers aren't scaled. It somehow implies it's different than a continuation of that fraction, right? When they're small like that, the 5-7.
Okay, the problem is, that the that it's nice to fuzz them out in gray. I don't disagree about that, but that 24 just looks totally crazy there. Why is it an error?
Well, if it's plus minus and it was gray too, it'd connect. The gray would connect to the gray. It's the plus minus can still.
Yeah, but it's
smaller.
Always plus minus is always going to be gray.
Yeah.
So how does one not?
Right. So you need the parens or something else.
Yeah, but by the time we've got parens, then we're in a bizarre situation. I mean, so let's just look at that case.
Can't we have like 57 be of larger font but still gray, and then plus minus 47?
Problem. Okay, well, let's try that case. Right. So the problem with that. The problem with that is that our usual notation there means plus or minus 47, not plus or minus. Okay, so here's another possibility, which maybe is too weird. Okay, here's another possibility. Do this, and we say plus minus ... 47. I mean, I think it's fairly clear. There's a slight problem with the fact that, I mean, so this will always be after a decimal point, right? This is never going to end up being to the left of the decimal point, I believe. Is that correct?
Well, we can have very large numbers as well with errors. We were discussing having automatic scientific notation for that.
Yeah, I think that's what we have to do, which means that they will always be to the right of the decimal point.
Right.
By the way, on the live stream, Adam Debrasani is asking, not all absolute errors can be represented as relative errors, can they?
Well, we could have 0 plus minus something. Perhaps that's
right, which cannot be a relative error.
Right.
but so what? Well, the only point that's making is a round form better not have, if a round form says show these as relative errors, the case of 0 plus minus 0.1 is hopeless.
Right.
Right. That's similar to what we get when we have a number that has, what is it? No accuracy. What am I thinking about? You know what I'm saying?
Yes, yes. We have error messages sometimes when we require too much precision or too much accuracy for numbers that do not have it.
Right. But so that means, in particular, what we do there, and it's not irrelevant to what we're talking about here, let's consider the case. How do I generate one of these? I would say...
I think we have examples in possible issues of number form.
Of number form, okay.
I think so.
You can write also one. Do you refer to this 0 backtick -1, for example?
Well, that's too extreme.
Okay.
Well, let's take a look at that case. Yeah, that case is, notice it's pinked.
Right.
And it says no significant digits are available to display. That's
Yes.
a case where we've basically said the precision of the number, that would happen even if it wasn't a 0 at the beginning there, right? If we say 1 backtick -1, we'll get the same result.
Right, and this is independent of number form. This is a property of the number itself.
Right, the number itself has no precision.
Exactly, yeah. So that's why I'm saying this is too extreme. I think here we have, exactly. Here we have error messages for numbers which are correct, just we are requesting something consistent.
The precision is small. Well, I think it's a slightly different case, but this, okay, in any case, this, look, basic bottom line, okay, let's go back to this idea here. Is this idea crazy?
I think it's understandable. I was a bit concerned with the fact of using dots, but...
It looks busy to me. That's my only, the artistic comment. There's just a lot going on there. I wish it was simpler. I mean, even parens to me is a cleaner version of that same case.
How would we do the parens?
Like above, I mean, before 57 and after 47. Yeah, like that.
Like this.
Right, but in the format we talked about for the other case. So gray 57.
Okay, all right, so let's look at that. Let's look at that idea. Okay. So you're proposing there that we would do this and we would parenthesize there.
Yeah, gray parens, yeah.
But what would happen? I mean, it's going to be a little weird because these parens, that paren, which we could make gray, let's just put it in there. That's a big paren and that's a little paren. So what will we do? We make that paren smaller.
Or the other one bigger. I mean, it's unfortunately big.
I think it would be better to do the other one bigger.
Are there other bracketing things we could do, like thin square brackets?
It is nice that the parens here remind one of the standard way to do this.
If they were thin enough, I think they'd look good. I agree that the standard ones at that font size look way too big. And
well, I mean, obviously this font size isn't the real font size because we typically will be seeing them as.
It'll look better at like a normal font size.
Fine. Well, let's try mocking this up and see whether you can give Jose a spec for how to implement this.
Okay.
But so then let's just understand the consistency here. So the consistency is normally the only thing that's gray is the stuff to the right-hand side of the plus minus on its right-hand side, because that means apply the plus minus to the whole number. In this case, the gray starts inside the main number. And we're indicating with parens which part of the main number. So we've got double indication of which part of the main number is being errorified, so to speak, is uncertain. Which seems okay to me. I mean, in other words, it's just, it's, Yeah, I mean, I think the real issue is, can we make the parens not look like this number? Because we don't have any other case where you would insert a sort of something like a diacritical mark or something in the number. I mean, the only other case we have is like recurring decimals and things where we have bars over them. Someone on the live stream is suggesting putting plus minus below or above the 57. I think that's not going to work. I think that's going to make a big mess, because basically it's usually quite important when we have arrays of numbers that the things have a fixed height. Well, is there any alternative we can see? I mean, is there any way to save this idea?
I'm using other characters that look like the parents that are.
Yeah, well, I mean, look, the concern that I'm having is breaking the number, because one feature of numbers, by the way, is that numbers have fixed width. Every character is a fixed width. So, for example, one thing that will break if we do this is if you have a column of numbers. Please don't send things. Okay. If you have a column of numbers, it won't align anymore. In other words, if you've got that paren, if I have a column of numbers right now, numbers in every reasonable font are fixed width, so that, you know, columns align. Am I making sense? But as soon as we put this mark in the middle of the number, it's not going to align, unless we somehow can make that mark be essentially between the digits. That makes sense?
Well, it's going to go off by the time it hits the plus minus at a scaled font. It's going to be off anyway. So you've kind of lost connection at that, you know, at the 408. It's all aligned, and after that, you know, no matter what we do, there's going to be some misalignment, I think.
Well, it's misaligned after you hit the plus minus. It's not necessarily, those last two digits aren't necessarily misaligned.
But we're just, you know, we're saving 2 digits here, and we know we're going to mess it up at some point anyway. It feels like we're not gaining much by saving those 2.
Right. But okay, so my question is, can we save this in any way? Is there any way, because that, honestly, the paren, I mean, one reason I like the paren is it is reminiscent of the notation that I've utterly failed to understand for probably 30 years or something since it first came in, which is super embarrassing. I mean, did other people know how that notation worked? Any other fizzy types here who
yeah, I did.
Okay. How did you know it?
Because I've seen it in the Avogadro's number. It's more or less standard in Avogadro.
Well, I know that. How did you learn? I think that came in. That notation came in sometime around the late 80s or something.
Mm-hmm.
Well,
I was thinking, in your suggestion with dots, what if we put 0 point, then dots, and then 47? So it follows the standard full number structure.
I see what you're saying.
And then we can have different types of dots there, because what I'm confused is about dots versus standard decimal dot.
This doesn't help Jeremy's busyness problem.
It doesn't. And is this ever these are always integers, the plus minus?
They are going to be integers because it is always to the right-hand side of the decimal point.
Yeah, and relative to what's gray on the other side. Okay.
Yeah, I don't think that's going to work. Yeah. Look, I think this is our best chance. Let's see if we can get decent mock-ups of this and go with that, and then go with the gray thing here and go with a pure. The only clue that this is a relative error is that it has a % sign.
Right.
Do we agree? There's no different graying, parenthesizing, or anything like that.
Right. Okay.
Mm-hmm. All right. Do we need Jeremy for anything else here?
No, I don't think so.
Okay. I'm going to go then.
Okay. We can, if you want to, we can continue some other day. I mean, this is just reviewing more.
Well, let's do a little bit of quick stuff here.
So here, this section is about independent data, and the next one is data with correlation. So that's the difference. This is a bit what we were, yeah.
So around replace here is doing something totally trivial, correct?
In this case, yes, it's what you expect. This would be equivalent to exponential of the around.
Otherwise known as just using replace here, or replace all rather.
Yes, in this case, it will be the same, yes.
Okay. So let's see, where does it get different?
For example, if you have two cases, then they may be independent or they may be correlated. It's what we were discussing the previous week with Gosia, the difference between around plus around and 2 times around.
Yes.
Because around plus around will assume they are independent, while 2 times around, it knows there is a single one which is multiplied by 2.
Right. So this case is what you're talking about. So in this case, the main point is to put in, okay, so this is our way of inserting 2 identical tagged arounds.
Exactly.
In those places. So the alternative approach, which I think we were sort of implicitly discussing, is, which I'm not advocating, is every around has a UUID. And you compare UUIDs to find out whether you think that they are correlated arounds or non-correlated arounds.
Right.
Is that, in fact, obviously completely bonkers to do that? So in other words, if every around, I mean, this is a way, so this is assuming that what you have, that you're always going to generate this. I mean, you could imagine having a key for every around and simply having the, you know, and the question every time you do a computation is, do the keys agree? If the keys agree, they're correlated arounds. I mean, there are only 2 cases that we're considering. They're correlated or they're not correlated, correct? Is Gosia here, by the way?
Yes. Well, it's not true and false only. We will have in general a matrix of correlation, which is able to interpolate the 2 cases. So there are correlation factors, yes.
But so wait a minute. So how, oh, I see. That's this case here.
Right.
Uggity-ugg. Okay. So your point then is that the only way to do this is to have, I mean, we couldn't do that. So my model of UUIDs is basically blown up by this case. A true statement?
Yes. Well, we still would have the difference between X and Y, which could be represented with 2 X's. So, yes. So if we have a UUID, it has to be on the variables, not on the arounds themselves.
Yeah, which means that we don't gain anything because we still have to have the variables.
Exactly. Yeah.
So we might as well call them X and Y instead of UUID blah and UUID blah.
Right.
Okay. So this allows us to get those 2 variables with that. So if I mess around with, if I take that expression and I mess around with these by putting some, let's say I put a big correlation there. What happens?
Well, this has to be a symmetric matrix. And the fact that it's so large I think these coefficients are typically smaller than
wait. Okay, so a symmetric matrix means that has to be, so let's say I have to put a 0.2 there and another 0.2 there.
Right.
Interesting. How do we, so the fact that has to be a symmetric matrix, do we allow a structured matrix in there? A
structured array, I'm not sure I do right now, but certainly it will work. It should work, yes. Or a sparse array. It shouldn't matter.
So in the case of 3 variables there, do we end up, we end up just with a 3 by 3 matrix, right?
Exactly, yeah.
But if we have higher order correlations, then we end up with a tensor, yes? Or is that not correct?
Yes, it's correct. It's what we were saying the previous week. We accept up to 4th moments, so you can have up to arrays of rank 4.
Okay, but those arrays of rank 4 are arrays with certain symmetry properties, yes? So they don't have nearly as many independent components.
Exactly, yeah.
But we're still representing them as dense arrays here.
Yes, but we could use a symmetrized array with only the independent components, yeah.
Okay. That seems useful to do. Okay, so the question here is, what is the question here? So the question here is, do we believe in this way of doing correlation? And I think this is pretty neat, actually. I mean, we'd worked this out a while ago. It looks quite sensible. I mean, these are complicated cases where there are correlated errors and so on. Right. You know, I don't know to what extent people will really use this. I mean, I think that
they are very important. For example, the examples further down on the GAM document, in most cases, they use this.
Fair enough. I understand that. I'm asking in kind of lazy folk.
Oh, I see.
You know. So if you're lazy and you just say exponential of around a blah plus exponential of another around, those two arounds will be treated as uncorrelated, right?
Exactly. Yeah.
So worst cases, you'll get too much error, correct?
Or too little.
How can you get too little?
Because when they are correlated, they have a tendency to add up. So it's the difference.
This should outer bound it like interval, though, shouldn't it?
Well, this is not interval arithmetic. So with uncorrelated cases, we typically get square roots of sums of squares.
Yeah.
With correlated errors, we get directly to the error.
I see. Okay. Yeah,
so
okay.
With uncorrelated errors, the error gets multiplied by square root
of 2. Like a random walk of uncorrelated errors, and it's a directed walk if it's a correlated error.
Exactly. Yeah.
There's a standard term for this model of approximate arithmetic, I think. I don't remember what it is.
Okay. But I'll find it. Okay, so what's the story here? Let's see.
Well, I just wanted to show the way we handle correlations.
That's not a... Wait. This is... What the heck is this? What is that? What is this form here? This is... Go ahead.
So this case is separating it's doing the same computation as the previous one, but rather than giving the full matrix originally, is giving the diagonal elements plus then some sort of normalized matrix. This is another way people specify the correlations.
By the way, just to respond to a question on the live stream, where could a round be used where random variables cannot? This is the problem with the fact that these live streams end up jumping into our sort of working meetings in the middle of long streams of discussion. This is the position of the thumb in this notebook indicates there was quite a lot that came before. The basic answer to that question, just to respond to it, is that there's probability distributions are fine if you know them and if you're prepared to work through them. This is dealing with a variety of approximations that are extremely, that are the only practical thing to do for working with experimental data with errors. And you don't even know the actual genuine, do I precisely have a Gaussian distribution or a Weibull distribution or whatever else. This is dealing with the case where you don't know that and you don't want to work through the full details of shattering the probability distribution into lots of pieces and all that kind of thing. Anyway, but back to this. Back to this. So again, I'm sorry. This is, if I just were to give, I see 2, 0.2. Go ahead. Go ahead.
So this is the notation that you have, like the means, the standard deviations, and then the correlation matrix. And above, when we had the 0.2 squared, that's a covariance matrix. So there are two equivalent ways to look at that. One matrix is standardized to have ones of the diagonal, and the other one has the standard deviations variances really there. So this is in a way that two ways to look at.
Okay, so when you're dealing with multivariate distributions, like multinormal distributions, do we also set things up with both of these possibilities there?
Only for the two-dimensional case. So when you have a multinormal distribution, we have a general covariance matrix. When you have a binormal distribution, for ease of life, we allow to have list of means, list of standard deviations, and then the correlation coefficient.
Okay, so hold on a second. So this here, this is just a covariance matrix.
Yes. So you have the mean vector, which would be our values, and then the covariance matrix, which would be corresponding to the matrix. So the list and
this matrix here.
Yes.
Okay. So this case here, where there's a variance and then a correlation matrix.
That corresponds to a binormal distribution, but that's only limited to the two dimensions.
But so in principle, okay, so wait a minute. So what we're doing in the, why is binormal, that's, I see. So in the case of distributions, you're saying we have a differently named distribution for the case where we're giving the covariance matrix versus giving a correlation matrix. Is that correct?
It's so multinormal distribution can take any dimension.
Yes.
Binormal, it's specifically 2, and normal, it's specifically 1.
Okay, I get it. But I mean, in the case of these numbers with errors, what Jose is saying is that we can, in principle, have, 3 numbers here, a three-dimensional case, and we can either deal with having a covariance matrix, which is a 3x3 covariance matrix, or, if I'm understanding correctly, we can have something in this form where we have a length 3 vector of variances, of standard deviations rather,
yes,
followed by a correlation matrix. Is that correct,
yes.
Jose?
Yes.
Okay, so what I'm asking is there an analog of that in our distributions?
No. For the 3 dimensions, you need to use the multinormal distribution. It's for the reason that you have the correlation coefficients, like row 1, 2, row 1, 3, row 2, 1, and then how would you, put them in an orderly fashion in a vector? It requires some ordering, and so for the sake of clarity and ambiguity, you use multinormal distribution for higher dimensions. So it requires.
I'm a little confused here because my understanding is Jose is claiming that in a round you can give 3 variables, 3-dimensional thing, with a list of variances followed by a correlation matrix.
I mean, it's converted.
It's very similar. So. For example, I don't have an example, but that matrix for the 2-dimensional case can also be a single number row, exactly like the binormal distribution. So these are just different notations that people use.
No, I understand that. But what I'm saying is, for example, if we want something which converts from our round setup to an approximating distribution, right?
Yeah.
It would be nice to have something which has, which has a lossless way of going back and forth, where it is recording the the error specification in the same form, so to speak.
I see.
Right. So, which suggests, Gosha, that there may be some way of representing essentially the multinormal distribution using this type of, instead of giving, because it is in fact unambiguous. I mean, if you were to give your capital sigma for your multinormal distribution in this form, right?
But in a way, it's inefficient because you give a matrix and you could give a covariance matrix, and in here you give a vector and then you give a matrix. So
sure, it's inefficient, but for some reason we think it's worth having here, because people independently think of the standard deviations from the correlations.
Yes, sometimes it's easier to think in terms of them separately because you understand better these ones rather than the numbers. But it's not a fundamental extension.
Right. Hey, listen, we should wrap this meeting. Several of us have the meeting about quantum stuff in only about 7 minutes, which we'll also be live streaming. So those on the live stream, if you're interested in watching that, please come back. I think we should wrap this meeting, and we need to continue with this around stuff How much more do we have? Do we have half an hour, an hour? What do we think we have?
It's not much more. It's just a few more examples. The most complicated things were the scaled and the typesetting. So I think we have advanced that today. And the rest are examples of things that,
okay,
from books and other things that the functionality does.
Complicated case. Complex numbers.
Yes, complex numbers are also complicated. Yeah. Mm-hmm.
We need to think about that. That notation is pretty cruddy.
Mm-hmm.
If we're going to do that, we got to have parens there somehow.
Right. Yeah. Yeah.
Or we've got to have, which I think will be better, and I don't know what the standards say about it, plus minuses for the real part and the imaginary part separately. Or does that not work because of correlation stuff?
Yeah, we'll have to think about it. It's because these numbers are exactly can be thought of separately.
That's the thing we have to discuss. I mean, I'm guessing this is going to need parens.
Mm-hmm, mm-hmm. Yeah, I do agree.
Okay, and Gosha, can we exercise a little bit of thought in that question of whether we need a different format to be supported for the distribution stuff to allow kind of round tripping there?
Sure.
Okay, all right. Let's wrap this meeting and see some of you in just a few minutes.